So we've reached the end. This is the very last screencast for the year, and it's going to be on electrolytic cells. Electrolytic cells are a type of electrochemical cell. And what we're going to be doing is we're going to be using a battery to supply power to make an otherwise non-spontaneous redox reaction occur. So remember that if it's a non-spontaneous reaction, that the E0 is going to be negative. Whatever voltage that is the voltage we need to overcome in order to get the reaction to occur. The energy comes from a battery. So it's funny because the battery is actually the electrochemical cell that we learned about previously, the voltaic cell. So we're going to use a voltaic cell to create the energy in order to do the work here. So when you hook up to a battery, there's a negative and a positive terminal. At the negative terminal, which this is, you can see it looks like a little negative sign, um, the electrons come flowing out of this. So the electrons come flowing out of the battery, and they come running down this solid piece of metal here. Since this is the negative terminal, this is going to be the positive terminal, and that's where the electrons travel back into the battery. So we take those two electrodes and we put it into a solution. And the solution will have positive ions and negative ions. The positive ions will be attracted to the negative terminal, and the positive ions the negative ions will be attracted to the positive terminal. When the positive ions get over here, let's say it's a metal, when that metal hits the terminal, it's going to absorb an electron and be reduced, and I'm going to get the solid metal. So it's a way for me to pull that metal out of solution. On the other side, you're going to take something that's negatively charged, an anion, some nonmetal perhaps, and it's negatively charged and it's going to be attracted to the positive terminal. When it gets to that terminal, it's going to go through an oxidation process, maybe turn into a gas, and it's going to release an electron. And then that electron goes back up into the battery to complete the circuit. All electrolytic cells follow this same basic principle. It's just what are you going to do? Are you going to do an electrolysis or an electroplating? And those are the two processes I'll show you on the next slide. But has to have a battery in order to be an electrolytic cell. That negative terminal is going to kick out negative electrons, so you're going to have a negative terminal and a positive terminal coming back into the battery. Anything in solution, anything positive is going to be attracted to the negative, anything negative is going to be attracted to the positive terminal. So let's take a look and see if we can figure this out. One process that's very commonly used is something called electrolysis. During electrolysis, what we're trying to do is take something that's really tightly bound together, like sodium chloride, and break it apart into its component elements. So how stuck are these and how much energy do I need? Well, if you determine the standard electrode potential, it would tell you just how strong the sodium and the chloride ions are stuck to each other. So I'm going to ask you to stop, look up the values, and then check to see if you can figure out what the standard electrode potential is for this. Okay, so what you should have had is that the cathode, the reduction, which is the sodium plus 1 going to sodium, is a negative 2.71 volts, and that the anode, the oxidation going from negative 1 to 0, is negative 1.36 volts. So we have a total of 4.07 volts that we have to overcome in order to get this reaction to be spontaneous. So that's what this battery needs to have. It needs to be at least a 4.07 volt battery. We hook it up, and at the negative terminal of the battery, remember the electrons come out. So this terminal is negative, and this terminal is then going to be positive by default. I take the sodium chloride, I put it in the water, and I melt it. So this is NaCl in the liquid or molten phase. So now I have the ion, since it's a liquid, free flowing in the fluid. The sodium ions, which are positive, are going to be attracted to the negative terminal. When the sodium gets there, it's going to absorb 2 electrons to go to sodium in the liquid phase. And that's how they make sodium that I use in the classroom for demonstrations or for whatever other processes that somebody might need sodium for. In addition to the sodium being produced through the reduction process, you also have chlorine, negative ions going to the positive terminal, releasing 2 electrons. So 2 electrons then leave and then go back up into the battery to complete the circuit. So the electron circuit is complete by having the positive and the negative terminal. Remember, at the anode, you always have oxidation, and the cathode is always reduction, no matter what type of cell, electrolytic or in a voltaic cell. So that's the electrolysis process, breaking apart a bond that's very, very strong. You can also take water and break water apart this way too. Okay, in addition to any other chemical that you want to break down, you can use electrolysis. Electroplating is another use of the non-spontaneous process in redox. Here, what we can do is we can electroplate something. Metals are pretty expensive, especially silver and gold. So what we can do is we can take an inexpensive metal, this one happens to be iron, and then coat the outside of it with a layer of silver so that it's not as expensive. So how do you do it? Well, you hook it up to a battery, and this is the negative terminal of the battery. Remember, the electrons come out of it, so this spoon is going to be negatively charged. The reason I have to have the spoon negatively charged is because I want the positive ions that are in solution from the silver aqueous ions. Remember, since it's a soluble salt, it will dissolve into silver plus nitrate ions. If this spoon is negatively charged, then the silver will come over to it, be attracted to it, absorb one of the electrons, and form silver solid. So along the whole outside of your spoon, the longer you leave it on, the more silver you're going to have attached to the outside. And that's how they silver plate jewelry, silverware, whatever you would want a silver plate. And it makes things a little bit more accessible. Now, in addition to electroplating silverware, you can actually chrome plate. Chrome plating is used, you can nickel plate things. This happens to be a chrome plating shop. So he's just about to submerge these pieces, I'm not even quite sure what they are, into a big bath. You'll see that they're attached to a piece of metal, and they're going to go onto this bar. This bar, or this bar actually, it looks, I don't know which one he's saying, either one, but they're hooked up to a battery so that the electrons can flow through it. And if the electrons flow through, they go down the wire. So this is all negatively charged. Whatever metal, it could be chromium, aqueous ions, floating around in this vat. As soon as this gets submerged, they come over, absorb the electrons, and that's how we get solid chrome on the outside of this, and that's chrome plating. Okay, so that's our 2 cells. We've got an electrochemical and electrolytic cell. If you want to pause and take a look at this, this compares the two, the spontaneous and the non-spontaneous electrochemical cells. Good? All right, have a good night. I'll see you tomorrow.